Hello, my name is Daniel, and today we will be going through the AMC 10A from the year 2005. So let's get started. First problem, while eating out, Mike and Joe tipped their server $2. Mike tipped 10% of his bill and Joe tipped 20% of his bill. What was the difference in dollars between their bills? Okay, so Mike, so $2 was 10%, and so 100% must have been $20. $2 was 20%, so 100% must have been $10, so 20 minus 10 equals 10, so the answer is D. Number 2, for each pair of real numbers A is not B, define the operation star as A star B equals A plus B over A minus B. What is the value of 1 plus 2 over 1 minus 2? So this would be minus 3 star 3, so this would be 0 over minus 6. The answer is 0, so it's C. Problem number 3, the equations 2x plus 7 equals 3 and bx minus 10 equals minus 2 have the same solution, x. Okay, so x equals minus 2 for this one, and so x should also equal minus 2. Let's plug in minus 2. Minus 2b equals 8, so b equals minus 4, so the answer is B. Number 4, a rectangle with a diagonal of length x is twice as long as it is wide. What is the area of the rectangle? So the diagonal is length x, right? So this is x. It's twice as long as it's wide, so its length is 2 times its width. So yeah, so this is let's say this is 2a and this is a. What is the area of the rectangle? So so root 5a is x, so a is x over root 5. A squared times 2, so 2a squared is the area of the rectangle, right? So 2a squared, this is 2 times x squared over 5, so this is 2 over 5x squared, and so the answer is B. Number 5, a store normally sells windows at $100 each. This week, the store is offering 1 free window for each purchase of 4. Dave needs 7 windows and Doug needs 8 windows. How many dollars will they save if they purchase the windows together rather than separately? A store normally sells, so it sells windows at $100 each, and so 4 windows is, so $400 would equal 5 windows. Right, but then Dave needs 7 windows and Doug needs 8 windows. So yeah, so if it's 7, then they would be saving $100, and if Doug is getting 8 windows and he's saving $100. But if it's 7 plus 8, this is 15, so they will save $300, right? So yeah, by the way, this is $100, this is not 200, and so they will save this much, 300 minus 100 and 100, right? So minus 200, so the answer is 100, so they will save $100. The answer is A. Number 6, the average mean of 30 numbers is 30 and the average of 30 other numbers is 20. What is the average of all 50 numbers? So 20 numbers is 30, so their total sum would be 600. 30 other numbers is 20, so their sum would be also 600. And so all 50 numbers, so 600 plus 600 equals 1200. 1200 divided by this 50, this equals these are crossed out, and so this is 120 over 5, so it's 224. Yeah, so the answer is 24. It's B. Problem number 7. Josh and Mike live 13 miles apart. Yesterday, Josh started to ride his bicycle toward Mike's house. A little later, Mike started to ride his bicycle towards Josh's house. When they met, Josh had ridden for twice the length of time as Mike and at 4/5 of Mike's rate. At how many miles had Mike ridden when they met? Okay, so they live 13 miles apart. So they are 13 miles apart. And then yesterday, Josh started to ride his bicycle. Okay, and so Josh had ridden for twice the length of time. So let's say Josh time TJ was 2x, and the time that Michael rode the bike was x. And his rate was 4/5 of Mike's rate. So speed was, let's say that Mike was 5 miles per hour, and let's say Josh was 4 miles per hour. 4 miles per hour, since that's a pretty easy way to putting it's a 4/5 of Mike's rate. And so how many miles had Mike ridden when they met? So this is wanting to get 5x, right? And so yeah, so 2x. So 13 miles is the total like distance that they're apart, and so this plus this, so 8x plus 5x would be equal to 13, so x would be equal to 1, so 5x would be equal to 5, so the answer is B. Problem number 8. In the figure, the length of side AB of square ABCD is root 50 and BE is 1. So this is also 1, 1, 1. And then what is the area of the inner square EFGH? Okay, so this is root 50 and this is root 1. So this should be root 49, and so this is root 49. That means that this is 7 minus 1. So this is 6. So this is 6, 6, 6, 6. So the area of the inner square is 6 squared equals 36. The answer is C. Number 9. 3 tiles are marked X and 2 other tiles are marked O. These 5 tiles are randomly arranged in a row. What is the probability that the arrangement reads XO, XO, X? Okay, so we have 3 tiles, X, 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 and OO. So we have 5 possible spots, and then we need 2 spots to put the O's, and so that would be total of 5 choose 2 equals 10 ways. And then what is the probability that the arrangement reads XO, XO, X? That is when it chooses these 2 specific spots. So this is 1 out of 10. The answer is B. Number 10, there are 2 values of a for which the equation 4x squared plus 8x plus 8x plus 9 has only one solution for x. What is the sum of those values of a? Right, so let's say that so it's 4x squared plus a plus 8x plus 9 equals 0. So it has only one solution. That means that the discriminant equals 0, right? So this is a plus 8 square minus 4 times 9. This is 0. A plus 8 squared equals 144. A plus 8 equals 12 and minus 12. A equals 4. And a can also equal minus 20 because a is 4 if a plus 8 is 12, and a is minus 20 if a plus 8 is minus 12. And so the sum of those values of a would be 4 minus 20 would be minus 16, so the answer is negative 16. It's A. Number 11, a wooden cube, n units on a side, is painted red on all 6 faces and then cut into n cubed unit cubes. Exactly 1/4 of the total number of faces of the unit cubes are red. What is n? Okay, so there's the wooden cube, that's n units on a side. So there's the cube, that's n units on a side. Yeah, n. And then it's painted red on all 6 faces and then cut into n cubed unit cubes. Exactly 1/4 of the total number of the faces of the unit cubes are red. What is n? Okay, so n cubed unit cubes, this means that the total surface area, total number of faces after the cutting equals 6n cubed, right? And then the number of painted faces equals the surface area before the cutting. So this is 6 times n cubed, right? So this is 6n cubed. No, that's 6n squared. And it's exactly 1/4 of the total number of faces. So 6n squared over 6n cubed equals 1/4. So these two cancel, so it's n left. This is 1/n. So n equals 4. The answer is B. And then problem number 12. The figure shown is called a trefoil. So the trefoil is it's this whole shape, and it's constructed by drawing circular sectors about the size of the congruent equilateral triangles. What is the area of a trefoil whose horizontal base has length 2? Okay, so we are wanting the area, but then notice that this trefoil can be cut into can be divided into 4 equal pieces that each have this much area, right? Because there's like obviously one more here, and then we have one more here, right? And then you have to notice that if we put this area and this area together, then we will have the same area as one of these as one of these areas, right? And so if we take it all away, then what we need to do is 4 times this much, and this much is 1/6 of the whole circle, right? So it's 1/6 times the whole circle, which is 1 squared pi. So this is 2/3 pi. So this is 2 pi over 3. The answer is B. Problem number 13. How many positive integers n satisfy the following condition? 130 n to the 50th power is greater than n to the 100th power is greater than 2 to the 200th power. Okay, so let's first focus on this one. 130 n to the 50th power is greater than n to the 100th power, right? And so n squared, yeah, so if we cut it all down by 50 powers, then this is also n squared to the 50th power. So this means that 130 n is less than n squared, so n is less than 130. So we have this conclusion, and then for this one we have we can see that n to the 100th power is greater than 2 to the 200th power, but 2 to the 200th power is equal to 4 to the 100th power, because 4 to the 100th power, not 1000th power, because 4 is 2 to the second power, so this is 2 second to the 2 squared to the 100th power, so it's equal to the 4 to the 100th power. So if we take off the 100th power, then n is greater than 4, so out of these two we get 4 and 130. And so, how many positive integers n satisfied? So 130 minus 4 minus 1 more, that will be 125. The answer is E. Let's go back to 14. Yeah, this is 14. Problem number 14. How many 3-digit numbers satisfy the property that the middle digit is the average of the first and the last digits? Okay, so let's say the 3-digit number is A, B, C, and then B has to be A plus C over 2, right? And so there are many ways, so let's start with what B could be. B can't be 1, B can't be 0, because that way A and C will both have to be 0, so that's impossible. So B starts from 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to 9. And if B is 1, A can't be 0, but C can be 0, right? And so if B is 1, then this can only be 1, 1, 1, 0. So I'll just write the A and C. So they will be 1 and 0. If B is 2, then it can be 2, 0, or 1, 1. And if it's 3, then no, actually, we have to make it as, if B is like this, then we have to make 2B, right? Then 2B would equal 2, 4, 6, 8, 10, 12, that looks like a 16. It's 10, 12, 14, 16, and 18, right? And so, now let's get to writing A and C, because A plus C has to be 2, 4, 6, 8, right? If A plus C is 2, then it can be 1, 1, or 2, 0. Let's write this in black. 1, 1, or 2, 0. If A plus C is 4, this can be 4, 0. So it's 4, 0, 3, 1, 2, 2, or 1, 3. And so these are from the 2, these are from the 4. And then and then from 6 there would be 6, 0, 1, 6, 5, 4, 3, 2, 1. So this is 6, so there will be 6 total. And then 8, there will be similarly 8, 0, all the way to 17. So this is 8. And from 10 it gets a little different because it's because it starts out from 9 1, because it can't be greater than 9, right? And so this is 9 1 2 1 9. So there are 9 numbers here. And 12, this would start out as 9 3 to 3 9. So this would be 3 4 5 6 7 8 9, 7 numbers. 14, this would be 9 5 2 5 9. So this is 5 6 7 8 9, 5 numbers. 16, this will be 9 7 2 7 9. This will be 7 9. So there's just 8 8 in the middle. There are 3 numbers. 18, the only way that this could be is 9 and 9. So this would be only one way. So these are 2 ways. These are 4 ways. So what we have to do is add all these numbers together, right? So it's 2. But then if you order them, it's basically 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, right? And then we all know that this is 9 times 10 over 2, which is equal to 45. So the answer is E. Problem number 15. How many positive cubes divide 3 factorial times 5 factorial times 7 factorial? Okay, so let's just write it all out. 3 factorial is 1 times 2 times 3. 5 factorial is 1 times 2 times 3 times 4 is 2 times 5. 7 factorial is 1 times 2 times 3 times 4 times 5 times 6 times 7. So this whole thing is 1, 2, 3, 4, 5, 6, 7, 8. 2 to the 8th factor, 2 to the 8th power, times 3 to the 4th power, times 5 to the 2nd power, times 7 to the 1st power, right? And so these would all go, and then this number would be this number. And so how many positive cubes? So if we want this to be cubes, then this will be 2 to the 6th power, so 2 to the 3rd power, 2 cubed, times 3 to the 3rd power. And that would be it, right? Because only 8 and 4 is greater than 3, and 2 and 1 can't make cubes, right? So this is basically 8 to the 2nd power times 27 to the 1st power. So this will be 3 times 2, since 2 plus 1 and 1 plus 1, that would be 3, and that would be 2. And so that would make 6. So the answer is 6. It's E. Problem number 16. The sum of the digits of a 2-digit number is subtracted from the number. The units digit of the result is 6. How many 2-digit numbers have this property? Okay, so we have a 2-digit number. Let's say this is 10a plus b. So we have 10a plus b, and we subtract the sum of its digits, so minus a plus b. The units digit will be 6. Would be something 6, right? But then if you look carefully, this b and this b crosses out, so this is basically 9a. So 9a equals something 6, and a is and a has to be a and a has to be 1 digit, right? And so that can only mean that a is 4, and there are no other possible values of a. So this is 10a minus b, so this will be 40 something. So this something can be from 0 to 9. So there are 10 possible values. So this property. So the numbers have this property only if it's only if it's 10th digit. It's 4. So there are 10 possible numbers. So the answer is D. And let's look at number 17. Number 17. In the five-sided star shown, the letters A, B, C, D, and E are replaced by the numbers 3, 5, 6, 7, and 9. Although not necessarily in this order, the sums of the numbers at the ends of the line segments A, B, B, C, C, D, D, E, and E, A form an arithmetic sequence, although not necessarily in this order. What is the middle term of this sequence? Okay, so let's just put the numbers that are on each vertice just like as they are. Let's say that the number that's in A is just A, B, C, D, E, like that, and then so the total sum of all all the sums would be 2a plus 2b plus 2c plus 2d plus 2e, right? And so this will be 2 times this all added together, 3 plus 5 plus 6 plus 7 plus 9. This is 2 times 8 plus 6, so 8 plus 6 plus 7 is 13 plus 9, right? So this is 2 times 21 plus 9. So this is 2 times 20, no, this is 2 times 30, right? So this is 2 times 30, this is 60, right? And then the sequence would be, let's say that the middle term is x, then it's x minus 2d, x minus d, x plus d, and x plus 2d, right? And so the sum of these, all these will be 60. So that means 5x is equal to 60, so x would equal 12, right? And so the middle term of the sequence is x. What we want is x, that is 12. The answer is D. Problem number 18. Team A and Team B play a series. The first team to win 3 games wins the series. Each team is equally likely to win each game, and there are no ties, and the outcomes of the individual games are independent. If Team B wins the second game and A wins the series, what is the probability that the Team B wins the first game? Okay, so the first team to win 3 games wins the series. So there are 2 possible scenarios. One is that A won first and then B won, and then the other is that B won and then B won in the second game. It says that Team A wins the series, right? So if we look at this scenario first, there is only one way. There is only one way that Team A could have won, and that is that Team A won the next 3 times consecutively, because if there had been a B in any of these in any of the past matches, like A B, then that would have completed B's third victory, and so Team A would not have won the series. So for Team A to win the series, there is only one way. So let's move this over here, and then focus on A, B, something. So here we need Team A to win the series, right? So the first it could go like this. It could go A and A could just win in 2 games, or A could win in 3 games and it could be like A B A, or it could be B A A. It can't be A A B, because then A A would have won by now. And so it's A B A or B A A. And if the game drags on to 4 games, then it could be A B B A B A, and no, so it could be A B B A, or B A B A, or B B A A. So A always has to stay in the last place, because Team A has to win. That means that A completes its 3 victories, and so A wins the moment that it completes its 3rd victory. So for A to win, A has to be the last winner. So that's why A is also here. And so these are all the ways I think that B could win. No. Actually, these 3 aren't possible, right? Because if B win 2 more, then B would have won right here. Same too for here and for here. So these just aren't possible, right? So what is the probability that Team B wins the first game? So this one, probability is 1/8, since this is 1/2. This probability is also 1/8, since this 1/2. This probability is 1/2, so it's 1/8. But this probability is 1/2 times 1/2, just 2 times, right? So yeah, so this is 1/4. So the total probability that Team A wins is that 1/4 plus 1/8 plus 1/8 plus this 1/8. And then team B would be in the first game, that's this one, so this is 1 over 8. So if you multiply by 8 to the numerator and the denominator, this would be 1, and then 2 plus 1 plus 1 plus 1. This would be 1 over 5, so the answer is A. Problem number 19. 3 1-inch squares are placed with their bases on a line. The center square is lifted out and rotated 45 degrees as shown. Then it is centered and lowered into its original location until it touches both of the adjoining squares. How many inches is the point B from which the bases of the original squares were placed? Okay, so what this problem is asking is basically asking us to solve for this length, right? But then what we need is just one line right here, straight line like that, yeah. And then so and then we will be able to see that since where is it? This is it. These are 1-inch squares, so this will be 1 inch, 1 inch, 1 inch. So that means that this would be 1 inch, right? And so this would be 1 over root 2 inches, right? Because this times root 2 is 1, so this is 1 over root 2. And so this is half of this whole thing, so this is 1/2. If this is 1/2, then this is also 1/2, right? So we get that if we put this again, yes. So we get that this much is 1/2, and we can also see that this is root 2, right? Because this is still a 1-inch square, so this is 1, 1, and this is 45, 45, so this would be root 2. So the answer is root 2 plus 1 over half. So this is root 2 plus 1 over 2. The answer is D. Number 20, an equiangular octagon has 4 sides of length 1 and 4 sides of length root 2 over 2 arranged so that no 2 consecutive sides have the same length. What is the area of the octagon? Okay, so let's say that that's the octagon. It has 4 sides of length 1 and 4 sides of length root 2 over 2. And notice that this this times root 2 is 1, right? And so what we get from this question is that this octagon was actually like that, right? So what it's saying is that this was length 1, and this was 40. That was 90 degrees. This was 45, 45, and this was root 2 over 2. Since that is the only way that this times root 2 is 1, right? So what is the area of the octagon? So if you see here, then these, like this side length is also root 2 over 2, right? And so this will be a square. This would also be the same square, same square, same square, and the same square. So there will be 5 of the same squares. 5 times root 2 over 2 squared. And then we would have these, right? So these two sum would be 1 of the squares, and these two sum would be 1 more of the squares. So we have 7 of them in total, right? And we don't need anything more. This is 7 times this squared is 1 over 2. So this is 7 over 2. So problem number 20 is 7 over 2. The answer is A. Number 21. For how many positive integers n does 1 plus 2 plus all the way to n evenly divide 6n? So we have 1 plus 2 all the way to n, and then we know that this is n times n plus 1 over 2. So this evenly divides 6n, so this is divisor of 6n. So 6n is evenly divided by n times n plus 1 over 2. And so if these n's are cancelled and this 2 goes up to, so it's 2 times 6, and this is gone. So this is 12 over n plus 1, and this has to be an integer, right? And so n plus 1 is factors of 12 will be 1, 2, 3, 4, 6, 12. And then n plus 1, these are n plus 1, right? So n would be 0, 1, 2, 3, 5, and 11. But then n has to be positive integer, right? So 0 doesn't count. There are 5 ways. The answer is B. It's 5. problem number 22. Let S be the set of the 2005 smallest possible multiples of 4, and let T be the set of the 2005 smallest positive multiples of 6. How many elements are common to S and T? Okay, so we want the numbers that are both in S and T. So sum of the 2005 smallest positive multiples of 4 and the 2005 smallest positive multiples of 6. So multiples of 4 and multiples of 6. So multiples of 12 are in that category, right? And then of the 2005 smallest positive multiples of 4, then it can go up to 8020, and 2005 times 6, this can go up to 12030, right? So this is so its maximum value is 8020 since it's the small number, and so this has to be smaller than 8020. This is a 0, by the way. How many elements are common to S and T? So what we need to do is divide 8020 by 12, and so this is equal to divide by 4 on each side, so that would be 3 over 2005, and so this is 3618, 2618, 25, so 8 times is 24, so this is 1, so this is 668 elements, so the answer is D. Number 23, let AB be a diameter of a circle and let C be a point on AB with 2 times AC equals BC. Let D and EE be the points on the circle such that DC is perpendicular to AB and DE is a second diameter. What is the ratio of the area of triangle DCE to the area of ABD? Okay, so the area, so 2 times AC equals BC, right? So let's say that this is 2, and this is 4. And the reason why I'm not saying that this is 1 and this is 1 and this is 2 is because AB is a diameter, right? And so its radius would be half of the diameter. But if I put this as 1 and 2, then the radius would be 3 over 2, and I don't like fractions. So that's why I put 2 and 4 here, not 1 and 2. And so the radius will be equal to 3, right? And then let's say that this length is h, right? Then DCE, so DCE is this length. This is this length, right? Because that's this height. So DCE is, let's say that this is F. Let's say this point is F. DCE, that is CF multiplied by h times 1 over 2, because that's the area of this triangle when we see that this is the base and this is the height, right? And then ABD, this is equal to this, so it's AB this much times h this much times half, right? And since this is perpendicular, that is the area of ABD, right? And so let's take this away and this too. And so so the ratio of the area of DCE to the area of ABD is this over this, so it's this over this. H so h is gone, 1 over 2 is gone, so it's CF over AB. But then notice that since but notice that since this is a diameter, this triangle and this triangle are congruent, right? So it's congruent. AC is 2, but it says the radius is 3, so this much is 3, right? So this much should be 1. And since this and this are congruent, let's move this 4. No, so let's move this 4 here. So this much, so this much is 4. And then since these two triangles are congruent, this must also be 1. So CF, this equals 2. AB, this equals the whole thing, which is 6. This is 2 over 6, which is 1 over 3. The answer is C. Problem number 24. For each positive integer n is greater than 1, let Pn denote the greatest prime factor of n. For how many positive integers n is it true that both Pn is root n Pn plus 48 equals root n plus 48? So, so Pn is the greatest prime factor of n. So, if the greatest prime factor of n is root n, then n must be a prime squared, right? And then Pn plus 48 is root n plus 48. Same thing, n plus 48 is prime squared. So if n is a squared and a is prime, n plus 48 is b squared and b is prime, right? And so if we put those two together, n is a squared, and we will put that into this n. A squared plus 48 equals b squared. B squared minus a squared equals 48. B plus a, b minus b plus a times b minus a, this is 48. And so this could be 24 and 2. This could be 12 and 4. This could be 8 and 6. And the reason that I'm only listing when it's even numbers is because b and a are both prime numbers, and they're not 2, right? And so b plus a and b minus a, they always have to be even numbers because b is odd and a is also odd. So these have to be even. So if it's 24 and 2, then b a equals 13, a equals a equals 11. If it's 12 and 4, b equals 8, a equals 4. If it's 8 and 6, b equals 7, and a equals 1. So Pn is root n and Pn plus 48 is root n plus 48. So we have 3 of these n's. No. Actually, a and b both have to be prime, right? So this one here, 1 is not prime, so this is not true. B and a, 8 and 4 are not prime, so this is also not applicable. So 13 and 11 are prime, so only this thing, so only this a and b pair can be n. So there is only one positive integer n that this is true. So the answer is 1. It's B. And problem number 25, last problem. In ABC, we have AB equals 25, BC equals 39, and AC equals 42. Points D and E are on AB and AC respectively, with AD equals 19 and AE equals 14. What is the ratio of the area of triangle ADE to the area of the quadrilateral BCED? Okay, so we have triangle ABC like this. Yeah, I don't really think that's what I was going for. Yeah, this is better. Let's say that this is A, B, C. This is 25, this is 39, this is 42. D and E are on AB and AC respectively, with AD equals 19 and AE equals 14. So the whole thing is 25. Let's say 19 is just about here. And then AE equals 14. This is D, this is 19, so this will be 6. AE equals 14, so it will be about here, I think. This is E. This is 4. So this is 14, and this will be this will be 28, right? So what is the ratio of the triangle ADE to the area of the quadrilateral BCED? So it's this line. So we need to find the area, the ratio of this triangle to the ratio of this whole triangle, right? No, of this. So it needs to be to the area of this quadrilateral, actually. Here is where a formula for a triangle comes in. So let's say that this angle is called theta. then a formula that is very helpful here is that an area of a triangle that has side length A and B, and the angle between them is theta. Then for this triangle, the area so the area is 1/2 times A times B times sine theta. So this is 1/2 AB sine theta. So this is very, very helpful to us here, because why? Because it lets us get this area's ratio and also this whole triangle's area ratio, right? And so moving this formula up like that, then ADE it's this triangle. This will be 1/2 times 19 times 14 times sine theta, right? And ABC, this whole thing, ABC, this will be 1/2 times, this is 25, and it said AC is 42, right? So this is 42. So this is times 25 times 42 times sine theta. And so what we want is BCED. Let's write this in black. BCED. This is ABC minus ADE. This is 1/2 times 25 times 42. Sine theta minus 1/2 times 19 times 14 sine theta. This is 1/2 sine theta times 25 plus 25 times 42, 19 times 14, 25 times 42 minus 19 times 14. And so triangle ADE to the area of the quadrilateral BCED, this is 1/2 times 19 times 14 sine theta over half sine theta of 25 times 42 minus 19 times 14. So these two cancel, and so if we divide by 14, then this cancel, and that would be 3, right? So this is 19, and then 19, this is 25 times 3, this is 75 minus 19, this is 56, and then this would be 19. So this is 19 over 56. It's waiting for us here. The answer is D. So that was the last problem, and thank you for listening.